Topic for today is sets. So let's take a look at the definition of set. A set is a collection of well-defined distinct objects. Now, in this definition, there are two things to notice. Number one, the objects must be well defined and they must be all distinct. Sets are usually denoted by capital letters like capital A, capital B, capital C, and their elements are denoted by small English alphabets. For example, if A is a set of first 5 counting numbers, then we must name the set. A is equal to, all the elements must be enclosed within brackets. So 1, 2, 3, 4 and 5. Now this is a set of first 5 counting numbers. And if you take a look on the way I have written these, definitely every set must be given a name because set in itself is one entity. So it must be given a name. All the elements are the members of the set. 1, 2, 3, 4. They must be separated by a comma, which I have done here. And then all the members be enclosed in a bracket. So this is how we write sets. And the presence, for example, 1 is a member of this set, and we use the symbol, this symbol, that 1 is member of set A in mathematics. That's how we write 1 belongs to A. And what symbol will you use if you want to say that 4 is a member of A? Definitely in mathematics we are going to use this symbol that will tell that 4 is a member of or is an element of set A. But what about if there is an element which is not a member of the set? For example, 6. 6 is not a member of set A, and that's why if we have to, we will write 6 does not belong to set A. So that's very important to understand that how we are going to develop our vocabulary of mathematical symbols and terms, and that's the way to write it down, that if an element belongs to a set, then it should be that relationship should be cleared with this by using this symbol, and if an element does not belong to the set, then we should use this symbol. Okay, the next we are going to talk about is the order of elements. Order of elements. Does it matter that if we write set A as 1, 2, 3, 4, 5, or we write the same set 5, 3, 4, 2, 1? No, it doesn't matter. It doesn't matter that inside the brackets how the elements are arranged. That's none of our business. So it's perfectly okay to write elements in any order or in any form, and that's one thing that you have learned. And next is that how do we present sets? Like, this is one way of writing sets, and the next, okay, we are going to write presentation of sets. Presentation of sets. And basically that's how any information for in our real life, that sometimes you see that we read sentences, that's the common man language for the people, those who have nothing to do with mathematics. They only understand just simple English language, and we should be able to communicate our ideas to them in plain English. And that's called the descriptive method of presentation of sets. So that is descriptive method. Descriptive method. And what is a descriptive method? For example, the example we were just talking about, A is a set of first 5 natural numbers. A is a set of first 5 natural numbers. Well, in a bit we are going to explain what are the natural numbers, but for now just take them as a counting numbers. A is a set of first 5 natural numbers. This is the statement. If you tell somebody that A is a set of first 5 natural number, if that person understands what the natural numbers are, he probably is going to get the meanings. But the people, those who are little bit easy with math, if you want to talk to them or communicate to them in this way, the way we just learned, A is equal to this 1 2 3 4 5. They are going to understand that this is a set of first 5 counting numbers, and you named it. You put the brackets, and then you separated each of the element of the set by using a comma. And there is a third description. There is another way of describing, and this is purely when math people will talk to another, or the language which science will speak while describing sets, and that's quite scientific. A is equal to, we'll give a variable name for the members of set. Let's call them X, and then qualify X with the criteria that where X is going to get the values and what is the specific criteria upon which X is going to take the values. And we just draw the vertical line, which means where X is what? X is X is a member of set of natural numbers, but then we lay down the restriction, and semicolon means, just like in our common English language, we just pause. So that's end of the statement symbol, that's semicolon, and then X is less or equal to 5. So this is the way. And this last one, number 3, this is called a set builder notation. And set builder notation, and this is called the tabular form. And the first one, as I wrote above, is a descriptive method for writing the sets. So now you have learned 3 ways for the presentation of sets. And what is next? Next we are going to illustrate a few terms which are very important, because in the structure these terms are going to make our vocabulary. So what do you mean by a null set? Null set. So okay, sometimes we come across situations where we want to describe a set, but there is no member that is going to qualify to be included in that set. For example, if you say that a city in Canada where there is a set of cities where no humans live. Okay, is there a city in Canada where nobody lives? Probably, I don't know if there is one, And that's why if I am going to write it, I will write that, okay, let's call this hypothetical city as A and just perform all the actions the way we wanted to, but there is no element in it. So there is not Toronto, yeah, there are people. Winnipeg, there are people. Everywhere there are people. So there is no city which is without any human being. So that's why this set is called an empty set. And we can't list any member. And well, there is one particular notation for this, and that's null set is usually denoted by this symbol phi. So if there is no element present in a set, it is called a null set, and it is denoted either by empty brackets or by the symbol phi. And next one is finite sets. What do we mean by finite sets? A set containing finite number of elements is called a finite set. What do you mean by finite? I mean only the numbers which, 5 numbers or 20 numbers are countable numbers, like, which can be counted, and definitely there is an end of that counting. For example, the set of first 5 natural numbers is a finite set. So you saw that this a set containing only finite elements is called a finite sets. Just out of curiosity, if we say that B is a set of cities in Canada with population more than 1 million. So which cities are going to be part of this set? B, well, it's definitely going to include Toronto. I don't know which cities have how much population, but I'm just guessing that, okay, Winnipeg, okay, Montreal, and maybe there are a couple of more cities, Calgary, but let's say that these are the only 3 cities which have a population of more than 1 million. We are going to list them, separate them with a comma, and then give them a name, set B. And this is what is a finite set. And now we are going to talk about infinite set. Infinite set. Well, infinite set, as it is clear from the definition of finite set, a set which is not finite is called an infinite set. A set which is not finite is called infinite set. Well, what kind of sets would be those? Well, for example, if you take a set of all counting numbers and name it as set C, or well, typically the set of counting numbers is denoted by n, so I'm going to use the letter n, and the counting numbers start from 1, 2, 3, 4, 5 and so on. Is there an end? There is no end. Like There is 100, then there are thousands, then there are millions, then there are billions, then there are trillions, and keeps going on. So when there is no end, that is called an infinite set. And well, we can talk also about countably finite or countably infinite sets, but let's leave that term for some later discussion. And let's carry on to the next term, and that is a subset. So what do we mean by a subset? Subset. Okay, if A and B are two sets and every element of set A is also an element of set B, then set A is called a subset of the set B. So let me write it down. If A and B are two sets and every element of set A is also an element of set B, then A is called subset of B. It doesn't say that every element of B is an element of set A. It only says that every element of set A is also an element of set B. And the way we denote it in mathematics, we are going to denote it as A is contained in set B. Okay. Now remember that every set is a subset of itself. So that's quite interesting. So note that every set is a member. Every set is a subset of itself. So what does this mean? It means every set is a subset, is contained in itself. Like if we were talking about set A, then A is contained in A. So, and that's why every set we can say is a subset of itself. But is it a proper subset? No. Well, the proper subset means that if A and B are two sets and every element of set A is also an element of set B, but at least one element of the set B is not an element of the set A, then the set A is called a proper subset of set B. So at least there should be one extra element in B which doesn't come from A. Then A will be called a proper subset of set B. For example, proper subset. So proper subset, and well, if A is equal to, let's say if A is equal to A, B, C and B is equal to